Hey everybody, how you doing? It's amplifier.com here. Please don't forget to like, share, and subscribe at the end of the video. We'd really appreciate it. So, here we have a power supply, and this power supply is the mating power supply to that 3-tube 3.5 amplifier. So, the transformer in this thing has a secondary AC rating of 2650 at 1.5 amps. Not sure if that's an ICS rating or CCS rating. So, first off, you have 10 capacitors in here. As you can see, they have a voltage rating of 400 volts. If you take 400 times 10, since they're all in series, you come up with 4,000 volts. For some reason they have silicone all on the sides, and they have electrical tape on half of them. 2 are black, the rest are brown. So those will be coming out. I'll get a filter cap. You have 6 as a full wave bridge rectifier, 6 diodes per string. That's okay. I like to use twice what I have on the plate. That's just cutting it. I mean, it's okay, but I'll be adding a couple more. So I did the math ahead of time to make this go a little bit quicker. So, you know, take 2650, you multiply that by 1.414, since it has a full wave bridge, come out with 3,747.1 volts. Okay? So, I don't know about you guys, but I have more than 240 here. I have like 248 plus, but we'll just go, I have a unique service here, so we'll just go by like 248, because most people have at least 248. So, to figure out the amount of volts per primary volt, you take 2650 divided by the primary voltage, which is what the transformer is wound for. What it says on the transformer, 240. So you take 2650, which is the secondary voltage rating, secondary AC voltage rating, and divide that by 240, come up with 11.0 volts. So take 11.04, multiply it by whatever you're feeding into it above that rating on the transformer, let's say 248. So 11.04 times 248 come out with 2,738.33. So if we take 2,738.33 and I multiply that by 1.414, come out with 3871.99. So you got to remember, you have transients in the line, and the voltage can spike. You won't see it on the meter. It could just happen so quick. And you could easily surpass the 4,000 volts that these caps are rated for. So it's not fun when one of these caps pop. So you always want to have some headroom there. Okay? So if you notice, toroid on the primary. This time he has a fan that runs on 115 volts, made by Radio Shack. Also has a toroid on it. Got the high voltage meter. Got the 3 diodes in series. Those aren't rated for the total voltage that they have across them. That could fail, then you can end up with the full potential of the plate on the meter, which is no good. This time the Millen connector is isolated from ground. It looks good. So, once again, painter's tape. I don't know what's up with the painter's tape. So, he has holes here. I'm not sure if the fan's blowing or sucking. I have to look at it, but so he's drawing air in through holes in the bottom and up. There's nothing wrong with that. That's okay. But so that's that. I'll be right back with the bottom. Okay, here's the bottom. Here's the delay. Is it like taped in with? It's like maybe painter's tape or something. I'll put the other type of soft start in. It'll have the time delay since the 8877 is an indirectly heated cathode tube, so we'll have the 3-minute delay. You got the soft start resistors. Once again, ferrite. So some of the stuff in the top ran on 120. He has a cord. It's a 3. I don't even know where it is. I think it's buried. It's a 3. As you can see, it's a 3-conductor cord. Ground, hot, and hot. No neutral. So all of the 110 stuff is the neutrals are bonded right to the chassis. You should have a separate neutral when running anything on 120. So he has 15 amp circuit breakers protecting everything. The plate supply, everything, fan, everything in the top. So if you do the math, it's not rocket science. You know, just on the transformer, if you took 39, if you took the total kVA, you know, the 30, take 2650 and you multiply that by, you know, the secondary AC voltage, 2650, and you multiply that by 1.5, that comes out to 3975. That's 3.975 kVA. If you took the 3.975 kVA, the 3975, and you divide that by 240, that's 16.56 amps right there. And you can pull more off. If this transformer is rated for CCS, you can pull up to 50% or so more than its total 1.5 rating for intermittent periods. So, way too small. Way too small for the transformer alone, let alone, you know, you have the stuff in the RF deck. You know, you have the blower, I mean, you have the fan, you had the, you know, you had the filament transformer, and, you know, the relays and stuff. So, I'll be redoing that. So, you know, and if you had 248, same thing, 3975 divided by 248, and then the current goes down just a touch, you know. But, so, that's it. I'll be right back. The bleeder resistors are across each cap. I've not taken this board out. Who knows what they are. I don't have time right now to pull the board out, so I'll find out later on. But you should always have a cap when you're using caps in series. If a capacitor isn't rated for the total voltage that you have on the power supply, you always want to have a resistor across each cap to equalize the voltage across each cap, so one cap doesn't have an unequal amount. If that happens, you could damage the cap and then it'll fail. You'll damage the you'll pierce the insulation within the cap. So, okay, this is the fan that came off the RF deck. I'm just going to show some parts. The RF deck's all taken apart. I started doing some work on it, so I'm not going to show that. But the fan's rated actually for 12 volts DC. I didn't even notice that at first. It draws 5.44 amps. Then he had the open frame relay, another open frame relay here that I don't like using these. It's contact. You can end up having issues with contacts when it's plugged into a socket. So you had this open frame relay. You had the 2 meters that had lights in them, all running off of this power supply. And look, this power supply is rated for 3 amps at 12 volts. So, yeah, that happened. So, all of this stuff's going back to the customer. Like I said, the original tubes, all these parts, tube sockets. He's getting everything back. I'm going to reuse this. I ended up buying 12 volt coils for the RJ1As that I have, so I'll reuse this. And I have some open frame relays that have 12 volt coils for the biasing and the other stuff. And the meters run off 12 volts, but the load on this won't exceed 2 amps. More like an amp and a half or less. So, okay, thanks for watching. Have a blessed day. Take care.